So welcome everyone. We should get started. For the benefit of those of you who are not in the room, who are watching the live stream or maybe watching the video later, we are in St. Louis, Missouri, where there's been much raining and flooding this past week. So thanks to all of you who are in the room for dealing with whatever hassles are between your house and here. Of course, we're glad that you're here. Thank you very much for showing up. My name is Jeff Brown, and I work for Object Computing here in St. Louis. We are I'm one of the co-founders of the Grails framework, and I lead the Grails practice at OCI. OCI, of course, is the home of the Grails team. The Grails team is spread out over, I think, 4 countries right now. 5 if you count Texas, where Ryan is from. So OCI is based here in St. Louis. We're the home of Grails, but also we've got we do business in a number of different areas. We've got an IoT practice, data analytics services, general software engineering. We've got about 140 or so engineers on the team.
DevOps.
DevOps is another area of expertise. That's right. We've got about 140 or so engineers. Many of those folks have advanced degrees in their field. We've got a lot of high-end folks. Please check us out at objectcomputing.com if you're interested in learning more about what we've got going on. RGA is OCI and RGA are the co-sponsors of this event every month, and this is just a super fantastic facility that we're in. And I'm really grateful that RGA helps us out by letting us use the facility here. So big thanks to Sean Crane and the rest of the team here at RGA for helping us put that in place and get that going. A couple of logistics related to the facility here is at the end of the night when you leave the building, please exit through the door at the top of the stairs, not this door, but the door up there. And when you go out that door, it's probably the way you came in. If you go that way, the stairs are right there, and it's a familiar territory. It's the way that you probably came in. But exit through that door at the top, not this door. Before we're done tonight, if you need to use the restroom, please come down here, and there'll be a security guard out here. If you're not an RGA employee, if you don't have an RGA badge, you need to not be walking around out here without an escort. So if you need to go to the restroom, exit through this door right here and turn to your left. There'll be a security guard. He can point you in the right direction. So please respect that. RGA is, as I said, I'm grateful that they let us use the facility here. So it's important that we respect their security concerns. So thanks for your help with that. Ryan Vanderwerf is here. Ryan is on the Grails team at OCI, has been for a long time, and for an even longer time has been an active member of the Grails communities. Well-respected, super sharp dude, and we're really glad to have him here tonight to talk about Grails and Alexa. He flew up from Austin, Texas this morning, primarily for this event, and then heading back home tomorrow. So big thanks to Ryan for weathering the trip to get up here, and I'll turn it over to you.
All right, my pleasure. Ryan. Thanks, Jeff. All right, let's talk a little bit about Alexa and Groovy. I've got a variety of devices here. 2 of these are Alexa-based devices, and then we got a Google Home over here. But let's just go over a little bit about what these are. How many people here have some kind of Echo? Yeah. How many people here have some kind of Echo or Google Home type of device in their house? So we got a few. Definitely, I think the dot hit kind of the hockey stick effect after this Christmas. One of the metrics that I found was the Facebook group went from about 500 users to like 30,000 because they were so cheap and everyone bought them around Christmas. So there's a lot of people using them for a lot of interesting things, which just makes this topic get better and better. So I've given this talk before, but I'm always adding new stuff. It's evolving very constantly. Lots of new things are always being added. All right, a little bit about me. Jeff said I'm a software engineer at OCI on the Grails team. I've got 2 kids under 12. I also help run a Groovy and Grails user group in Austin, Texas. I've done co-authored a video series for Gradle implementation, Unpacked. Just like to hack on lots of things, anything home automation, cars, phones, gadgets, IoT things, DevOps stuff. It's all good. So what are we going to cover? What is Alexa and what devices it covers? How does it work? Kind of the evolution of UI and why this is relevant now versus before. Some of the software concepts and components. We're going to talk about how we use lambdas in Groovy to make stuff. And we'll kind of show how to make an app with that. We'll show the Groovy podcast skill, which is a live thing you can run right now on any Alexa device. You can ask it to play the latest podcast or a podcast episode, and whenever they post a new one, it'll automatically be there. And we can do more things with Grails, like account linking. Oh. And using Grails and all of its great plugin ecosystem with things like Spring Security and OAuth and all those things, you can do a lot to make a really rich Alexa app that has a user interface with accounting and linking to things that are, personal or unique to you. I'll talk a bit about VictorOps skill, which is something new my friend Lee and I have been working on that lets you monitor systems remotely through Alexa. All right, what is Alexa? It is this architecture here where basically we talk to a device, it talks to a cloud service, and then if you want to run any special features or skills, that's going to go ahead and talk to your application. Your application talks back to the Alexa service, and then a service talks back to your Echo. You never have any kind of direct intervention with the user ever. So they don't trust anyone enough to give access to their home device. So you're always going through a proxy of their service. And that filters out and scrapes things and checks for you doing nefarious stuff to not let you through. And then your app also has to protect itself against nefarious attempts to make it want to trigger things. These are the main devices. There's one new one came out called a Look. It's a little camera. It's in private invite only for it, but apparently it will take pictures of you, what you're wearing, and give you suggestions, and maybe that's not such a great idea. So those of you who aren't married or something, or have a girlfriend to tell you maybe that's a terrible outfit to wear before you go out, maybe that would be helpful. Or I know a lot of women like that for maybe fashion tips. It's an interesting concept. We've also got this guy here is a tap. This one has actually gotten a little more functional. So it used to be you had to push this button on the front of it for it to respond. It would not listen. Now you can program it in an always on mode if you want, where it'll always be listening for the wake word, and it'll keep working as long as the battery is before it dies. And that's pretty neat because it used to be a kind of a limited thing, and they didn't sell many of them because of that. And then here's a Dot. This is the cheapest thing. You can get a refurbished one for about $42. Or a new one for about $50. Sometimes they're on sale if you buy multiple ones. And then the big one here is the Echo. It's got a really nice rich speaker in it. It's the most expensive kind of granddaddy of them. So basically things Alexa can do if you're not familiar with using it. You can ask it, what's the weather? You can ask it, tell you a joke. You can make it play music, play podcasts, look up recipes, add things to your shopping list. I use it frequently in the kitchen as a kitchen timer. That's a good one. You can do reminders. You can hook it to your Google Calendar and make it reminders of appointments. So you say, what do I have to do today? It'll tell you what appointments you've got to do. It's neat. This is what an Echo looks like taken apart. There are actually not a lot of components in it, really. Most of that's to drive up the nice audio and subwoofer. It's kind of a dumb pipe, right? Everything that smart it does is going through their cloud service. It's just a dumb pipe that kind of pipes everything back up to them, and then it's doing all the speech recognition and analysis and processing and going to skills and back, and then comes back down to your device, and you've just got a speaker. What makes these things work good, though, is they have a multi-dimensional mic array. So there's several microphones spread around the top of it, and that's what makes it understand you pretty well in a room. And that's really the difference of these things, right? We've already had Siri and the Google talking thing on the phones for a long time now, right? But not the always on thing in a home is kind of the difference here as far as the evolution. Here's an original Dot version 1. Those used to be about $100. Now these version 2s have less stuff on them and they're cheaper. These are nice also because you can have a audio out jack on them to hook to an external speaker, because the one that comes with isn't that great. Just enough really for kind of voice talking and audio. All right. And here's the tap. This is what it looks like, a kind of a cut see-through version of it. It's just a battery Bluetooth speaker, but it has Alexa built into it. And I would say this tap and this Google Home probably have about the same audio quality as far as playing music and things like that. The Echo's got a little more subwoofer oomph. Another thing that people forget about is if you have an Amazon Fire TV. Does anyone here have an Amazon Fire TV stick in their house? So a lot of cable companies just give you these things now. They're so cheap. So we got one guy. You can do all the same Alexa stuff for the most part. Anything you've got enabled in your own account that you want to develop for yourself, you can access it on any of your devices, including a Fire TV. So the only thing you can't do is like the timer function or the alarm. That doesn't work on that. It'll tell you not implemented if you try it. But yeah, it's pretty cool. So all those things kind of work the same. And there's other things here like the Google Home we've got. They've got a SDK. I'm working on a talk for that right now for Great Conf EU to show what you can do with that. There's another one called Ling Long Ding Dong. It does Chinese, and one unit does Mandarin and one does Cantonese. It's a funny name, but it is a real thing. It's actually kind of impressive because those are very hard languages to decode and map to things. And they've actually had pulled that off in kind of around parallel what Amazon was doing. You can also do it with your own Raspberry Pi if you'd like. So if you've got a Raspberry Pi, there's a link here where you can go download all the stuff and put it on your Raspberry Pi and hook a microphone up to it and make your own Echo Alexa thing. All the source for all these devices too, it's open source. They don't have it on GitHub. They just have a zip you download. It's an export out of their repositories internally. It's got all the source code that runs on each one of these devices. So if you want to look through it and you suspect it's doing sketchy stuff, you can look for yourself. All right, back to Alexa skills. So how does it work? App developer never talks directly to the device. A no-no. These things only really can talk with the exception of an alarm or timer, which is a local function. You can never make one wake up and start screaming at you or something. They figured people would be hesitant to buy these things if they could just, thing out of the blue started doing crazy stuff. I think it freaks people up enough when it picks up a false signal. So always it has to ask to initiate something, and then that goes to the Alexa cloud service. If it's something built in, it handshakes back. If it goes to a skill, then it's going to go out to your server, your Lambda function, or your Grails app, or whatever you're making. It's just talking JSON, really. And then that goes back to Alexa, and that goes back to you. Everything's all JSON. You can do small sound clips interspersed with the text using a format called SSML. I'll show you how to do that a little bit later. Or you can do audio streaming where it's like a long-term thing, like playing a podcast. And I've got an example of that as well. And you can run it as a Lambda function or as a web app, as long as it's got a valid SSL cert. So this is kind of the evolution of UI, right? We started with character-based interfaces, web interfaces, mobile, and then we've gone to these old green screens. We had readability issues and things like that. So we're trying to evolve this kind of interface in the home for when your hands are busy. You know, we've evolved to heavyweight GUIs, things like that. Lots of stuff on the screen. We've gone then after that to web interfaces. Right? Mobiles had been the nexus thing, and I think voice user interfaces is the next kind of hot thing. A whole concept of there's chat ops, right, where you're doing chatting with Slack and you're controlling robots and doing things. Well, the next evolution of that is kind of talk ops, where we're going to hook into those same things, but we're going to do it by initiating commands verbally instead of typing them. All right, what SDKs do we have? We've got a skills SDK. There's a voice SDK. I'm not going to talk about the voice SDK. If you want to build your own Alexa-based hardware device, all of that stuff's open, and you can make your own with their voice SDK. So if you want to make a new whatever, a refrigerator that talks to you, you can use that and implement that and have fun. They also have something called a flash briefing SDK. Really, that's kind of an RSS feed reader that you can pre-configure. We're going to talk about the skills API. That's the part that's fun, I think. They also have kind of a home SDK. Only supports Lambdas. It's for home automation things only. It's kind of a offshoot of the skills SDK. All right. We talk all this talking back and forth. I've got framework examples and API and SDK for you, but really at the end of the day, this is just talking JSON back and forth to a service. Some of the things you have to do in the SDK, it does for you though. I mean, you can write your own if you want, but it ends up getting kind of complicated. You need to validate the request and call events. So there's a hash signature that comes in. There's a timestamp you can check on it after the hash if you decode it to know if somebody's doing a kind of replay attack. You can block those. There's an application ID that when Alexa talks to you, you can verify that whatever you were contacted with matches your application ID that you're expecting. So all of those things can help vet out someone who's just messing around with your server, because your server has to be open on the internet for Alexa to call you. We can build things called card responses. So if we look in the Alexa app here, there's a concept of a card here. So if I go home, these are cards. This is the visual representation a skill can bring back. They're somewhat limited. You can do kind of simple pictures and text. You can't do HTML, but the built-in ones Amazon's made obviously can do more. But so your skill that you make can respond with this and say something back. And they don't necessarily have to be the same thing. For example, if you had links to HTML or Twitter hashtags, you don't want it to say them, right? Alexa's going to say HTTP, blah, blah, blah. That'll be really annoying. But you probably would want that in your card so you can click on it and get to it later. All right, let's look at some specifics. So this SDK here, I've forked. They've been somewhat slow on updating their Java SDK. They made one initially pretty quickly, and then they kind of dropped maintaining it. And what's ended up happening is they put it on GitHub. A bunch of people improved it, sent pull requests to support all the new features like audio streaming, multiple languages, things like that. And then what happened was they didn't merge any pull requests in or manage the project at all. And apparently that's a problem at Amazon they have, where all of their GitHub repos have started going into what GitHub grades as poor health. And what happens is occasionally they'll come in and just do a mass dump on top of the GitHub repo of whatever they were working on internally. And then the pull requests are still sitting there. So I forked their project, merged all the pull requests into one cohesive thing, fixed all the bugs, and then finished it out to where all the audio stuff works. And that's what I'm hosting and using these skills with right here. They're all, the SDKs on bin tray, so you can just access it and use it and have fun with it. All right, let's talk about how to make skills. There's a few things that make up skills. One is called an intent schema. So what this does is it tells an action that your app can do. So an intent could be, I want to save an item to my shopping list, or I want to ask for my favorite color, or tell it my favorite kind of ice cream, or whatever, or tell me what time it is. Those are all actions that would go into an intent schema. And then intents describe things called slots, which are parameters. So maybe I want to say, what's the weather like today? Or maybe I say what the weather's like tomorrow. That's a slot, right? I'm giving it a parameter in a sentence. And you can have multiple parameters inside of a sentence. And we use something called sample utterances. Let me show you an example of that. That would probably be the easiest. Sometimes things are easier shown than said. Here's the Groovy podcast. So here is a, can everyone see it okay? Is it? All right. a little better? Okay. So here's the intent schema. It's just a JSON document, and I lay out all of the intents that my skill is going to do. So I can, some of them are required. So if you want to pass certification, you have to support certain things. You always have to support help. You always have to support stop. In this case, it's an audio intent. So if it is an audio intent, you're required to support pause and resume, which is a bit tricky. I have this on my GitHub page here, so you can see how I did that with the DynamoDB database to keep state. Play the latest episode is the common one people do, and help, stop, cancel. Those are all things to get out of it and stop it. If you don't put that into your skill, there will be no way for you to exit out of the skill unless you power off your device, which can be very, not cool. So when you go through the certification process, they test all of that stuff for you, and they kick it back immediately if those things don't work. Slots. Let me go back to this. So slots are the parameters. So here I'm saying play episode, and then I can give it a podcast number. So if I say play episode 12, then that slot will map to a number. They have 100 different kinds or more of slot types. And so what it'll do is help it parse that back when you get something that's intelligible, right? So if you say it's a number, it'll give you numeric numbers back in your application. If you don't say number, what you're going to get is the number spelled out, like TWO or FIVE, right? That's much more difficult to deal with parsing and branching and doing code things with. So that's why they have that. They have things to help parse dates. They have even colors and all kinds of different things. And all these things could just basically reduce the error rate of it understanding you. Otherwise, if it's just trying to take everything as text and then parse it, the probability of success it's going to understand you gets lower and lower. So that's why these slots are kind of important, and you should use them as much as possible. All right, so we talked about slots. I've got links here, and I'll share these slides, but there's links that has the full documentation of all the different kind of slot types you can do. Now, what puts this together now is we map our slots and our intent schema to a thing called sample utterances, and this is going to train it to understand what you're telling it. So this is the phrases that activate intents. So it's a real simple listing of a sentence, and then you put brackets around your intents, and then or your slots, and then you can even repeat things over and over and over again. You can misspell things on purpose to increase the probability it will understand you. So you could repeat the same phrase slightly misspelled 500 times, and it's okay. And that will help train Alexa to understand variations of speech. It's real important if you want to do things like names. Someone had made a Pokemon skill, which is very difficult because none of the names for those things are really words. So what they did was they put in hundreds of variations of each one misspelt to help train it to understand when you say, I want to whatever, a Pikachu, it knows what that is. And I'll show you an example of that. It's really, really simple. Here's sample utterances. So here's the thing for the Groovy podcast skill. It's just play episode, intent is the name of it, and then the sentence that I want to say. So if I say play number, it will play episode intent and pass that podcast number as a parameter. Or I can say play number or play episode number. I could put even more variations of that juxtaposed around, and then it would understand, everyone's kind of conversation-y way of talking to it. And the more of these things you put in there, the better it gets. It does try to help you with that a little bit. If you give it enough, it can drop certain words out for you and still understand. Here we've got play latest episode, so it will then go find whatever the latest one is and play it. Then we've got help and stop and cancel. You could put basically variations of stopping, like, if you swear at it, it'll do something or whatever. Actually, there is a built-in way of swearing at it, it'll stop. I found out it's synonyms built into the system as well. All right. The Alexa app is how you set up everything. That's what I just showed you here with the cards. This is the Alexa app. You can go to it via alexa.amazon.com, echo.amazon.com from your web browser, and then you can log in and automatically get to your devices. You can also use the mobile app on your phone. I find if you want to get on a Wi-Fi that requires some kind of logging in intervention, like accepting terms and conditions or whatever, it works better if you use it from your computer and do that. And that's definitely one leg up that it has over the Google Home. Google Home, I've never gotten to work on any kind of thing that wasn't a simple password network for Wi-Fi. And so here we can do shopping lists, things like that. There is an API for shopping lists that's been kind of pending for a while, and it's still not really out. I guess they're trying to get it right. How you find skills. So they apparently made a big change recently. So currently you have to go into that app and find them. And if you want to make your own skills, what happens is you go into skills here, and there's normally like a store here, so we can browse around and look for different skills. But if you want to make your own and you publish, but you don't want to share them with the world yet, maybe they're not approved, so you can't, you can go into your skills, and then everything you've done yourself. So I've made one called Victor Ops. Let's see here. It's just my basic one that it's not public, but I can access it because I've logged in with my Amazon account, and that's what's synced to my devices. They do have a new feature also called beta. So even though it's not published, you can do a beta test, and you can give it a list of people you can send it to with their Amazon account, and they can now access your thing, and you can share that with them for sort of early access, which is really, really nice because they're doing a lot of work QAing your skills for you, and if you can get someone else to QA your skills before you send it to them, they're gonna that's less time they have to spend, because they're no joke about testing all these things when you submit them. It's a large amount of effort, and I'm really shocked it's free, because I've submitted a skill 8 times and didn't get it, accepted till the 8th one, and I had to wait 3 days, and they checked everything manually by hand each time. All right, so we've got cards. We showed you that's the response that appears in the Alexa app. So that's what you text and things like that you would want to put there, but not say them. Similar to Android cards here, I'll show you an example in the code here where there's simple or standard, or there's a kind of card called a link account card. And we'll talk about that in the Grails app part, where basically if I need something like a Twitter skill and I wanted to search through my Twitter, well, I need to somehow link my Twitter account to my skill so that it knows to search my Twitter account, not someone else's, right? I don't want some canned Twitter account. The mentions and things like that wouldn't matter to me. And they do limit what you can put in here. Again, no HTML, stuff like that, unfortunately. An icon for a standard type or a text only. All right, to open it, you can always open and ask. You can also do shortcuts. So I can say something like, computer, open Groovy podcast. Computer, open Groovy podcast. Thinking about it.
Welcome to the Groovy podcast skills. To start playing a podcast, say play episode number or say play latest episode.
So now I can continue the conversation, but I can also take a shortcut. Stop. Come on.
Starting playback of latest Groovy podcast episode.
Good morning, good
Stop.
afternoon, and good evening. And
Computer,
welcome
stop.
to the-
Okay, and I can say,
Pausing playback. Say resume to restart playback.
okay, now I could say something like, computer, ask Groovy podcast to play latest episode.
Starting playback of
So I can
latest
jump ahead,
Groovy
right? I can
podcast
stack the
episode.
commands and go directly
Good
to
morning,
something
good
instead of having to
afternoon, and
navigate the
good evening,
menus.
and welcome to the Groovy
Computer, stop.
podcast.
Pausing playback.
So that works on any of your skills. That's automatic. You don't have to do anything. It figures that out from your intent schemas. All right, we've got our intents. So the way these are mapped in the code here, so all we're doing is responding to events. So you can either have a Lambda or a Grails app. That's back to the Grails app's backed by a controller that you just implement an interface that says on launch, on session started, on playback started for audio and things like that. And then, you know, if things are failed or whatnot. And that's how we do and route all the calls in for commands for intents to make things happen. On intent being the main one. We can do audio player directives, just like here with this Groovy podcast skill. This is a newer thing where you can actually stream audio from another source, like a podcast, or even play your own music collection that way if you want. You know, as long as you're not streaming the data, then you're not having to pay for it. So those directives are called audio directive play, stop, clear queue. You can queue things up to play, so you can have like a playlist of stuff going, and then skip to the next song if you want, and do controls like that. Yep, we can do something called SSML. This is pretty nifty. So one example of that is here. I think I've got one here that's published called, my friend Lee made, called Hero Quiz. Computer, open Hero Quiz.
Welcome to Hero Quiz. I'm going to ask you 10 questions to test your comic book knowledge. Say a repeat question at any time if you need to hear a question again, or say help if you need some help. Let's get started. Dazzler's power is to absorb light and convert it to what? 1. Explosive energy. 2. Light.
Computer, stop.
3. Louder sound. 4. Silence.
Computer, stop.
Okay, I'm going to stop the game now.
There you go. So that's responding to a stop intent. I didn't have. We used to have it playing an audio snippet in there, but basically it's really picky. You can play audio snippets in it, so you could make a guessing game, a trivia game where you played the sample of a song and it's like guess that tune or something like that, right? And then you could have all these little samples recorded and then play them, and then they would have to guess multiple choice question A, B, or C. That a particular app's using a DynamoDB database to quiz you on superheroes. And that's also running a Groovy Lambda. It is really picky about the files, though. If you want to do that, here's a cheat command with ffmpeg that will get you a file that it will like. It's really not helpful. If you give it a file it doesn't like, it will just give you a weird error, and it won't be helpful. And you'll scratch your head for a while. So, yeah, do that. Here's what SSML mark looks like. This is something that's becoming a common thing, that even becoming a standard. This is playing, for example, here, just a little snippet of audio. And then I can add some text here after it. That's an example of using SSML markup. And right now, you just certainly have to stick that in strings and build it. I don't have any fancy builder right now for it as of yet for SSML. But there's a lot of different features of SSML. You can make it help say numbers, help enunciate things in certain languages. You can do canned ways of saying things that sound really natural. So you can tell it to do those instead of reading text back. So, for example, they've got one that's like hello and goodbye, and they sound real natural and fluid because they're pre-recorded kind of samples. And if you mix that into your application, it sounds very natural and real. Another one where it can do digits, and it can say them in a certain way. So you can spell them out and say, like, it'll say two or TWO, or spell out things. You can, if it can't say something right, you can kind of tilt it easier to say a certain word that maybe sounds wrong. If you can do this, or you can try to cheat and just misspell the name phonetically, and it might sound better coming out. All right, so you want to test this stuff. How do I test this? You don't even necessarily have to own any of these devices. You can go to a website called echosim.io. You can just log in with your Amazon account. This is a legit endorsed by Amazon thing, where it's just a web browser interface, and it'll use your computer microphone. And you can test your skills out there without even owning any of these things. So that's definitely usable. You can also use the test. There's a test tab here in the developer console. Go to developer. You can create an account here. It's free to make your own skills. You just sign on developer at Amazon.com, go to Alexa, go to Skills Kit. Excuse me. So this is the live skill. And then here's development ones. And they've added really cool stuff, so I can know how much metrics are happening on things. They've added. So here, this is how many unique customers, new people used it in the last 7 days. I got 7 things. Last 7 days, we got 14 sessions of people using it. So it comes up and down. Some weeks I get over 60 or 70. And it's really cool because you can kind of know how, if people are using it or how they're using it, and what they're doing with your skill, so you can maybe improve it and maybe make the parts people like better, or maybe they're not using a certain feature because it's not very easy to use. But the cool thing here, let's see, so we can always test it. No, this one I can't because it's not published here. There's a test tab. And I can actually just type stuff. You know, simulate it would be a text. Oh, no, it's right here. Open. So here's what gets sent to the skill from Amazon side. And this is what my service, my Speechlet, responded with. So this is a Grails app spitting this back using that SDK. And it is very picky about the format. So that's why you want to use something like an SDK. Otherwise, you'll just spend all your time trying to tweak it just to where the Alexa service likes it. And if it doesn't like it, it'll even try to alter it and make it work. And then you won't really know if you're even sending that exactly. It might be something else and it's altering it because it thinks you're trying to maybe do something bad. It's not perfect. It does do multi-language. It's German, other than US, UK English. If you pick it to UK English, it'll actually be a guy talking with a British accent. And then there's German, I believe is also a man. I'm not sure. I don't know German. I'm hoping they'll do Spanish next because that's, I think, the next biggest one. It has trouble with some strong accents. I've met some people that have pretty strong accents and they say it works great. Some people say not so much. All right, we already showed you the Groovy podcast app. So that is a Lambda. So the way we run that is I have a lazy bones template you can use. It will spit out a Lambda Gradle-based project that you can get started. It's got an empty kind of project going, and it'll spit out something very, very basic. And that's what I built this thing from. And what it'll do is it'll create a 2 classes for you: a Speechlet request handler, and this is kind of a router. You don't really need to do anything with this; it just generates it for you. And then the only thing it checks for is your application ID for your Amazon. So it'll pull that out of your Grails config file, or your properties file in this case, because this isn't a Grails app. And then verify that when the request comes in, it gives you an application ID, and it needs to match your application ID, or it'll kick it back. And then we've got a Speechlet here. This is the heart of how it works. So and then we just override all of the methods. We've got on playback started. This is doing audio, so we're doing all those audio things. But what happens here is, first thing that happens is it calls on launch. This one doesn't really do anything. It says a welcome response. So it says hello. So if we look at my welcome response, this is when we first launch it. It's basically just saying here some text. Welcome to the Groovy podcast skill. All right, great. Then we go to a thing called an ask response. So there's 2 kinds of responses that you'll have: an ask response or a tell response. Tell response will say something and then be done and then it's over. Ask response is an interaction. So I can ask you something, you can say something back, and then we can continue that conversation. So in this case, we're going to do an ask response in this then, and then because it wants to know, what do you want to do? Play this latest episode, or play an episode number, or get help, or stop. Those are the things you can do, because that's what we mapped in our intent schema. And here, when we say an ask response, the only thing different is that it sets a card up, which right now is just using the text. In this case, it's both the same as the display and show text, but sometimes we don't want that, right, if there's a link or something. So we set that up, and then here we say, this is just kind of a helper thing it calls new ask response, which is part of the SDK. And then what happens after that is we get a on intent calls. So now we've picked an intent, say, it says we want to do something. Now I pick an intent, and we've got play latest episode intent and all that. So I've basically just got a switch statement here, looking for the intent name that got passed in after it figured out what it wanted us, what we wanted it to do based on the sample utterances, right? So sample utterances had the intents in it, and as we say play the latest episode, that's going to trigger the play latest episode intent. And then here we've just got a method called play latest episode. So this is kind of like your controller, especially in the Lambda, of how to break out all the intents that are running. So we've got play latest episode, play an episode number, resume, pause, stop, and help. And then there's another just default one we fall down to of like, I didn't understand what you were talking about, but can't figure out. It got some kind of intent, and it's nothing we know how to handle. It's going to say, I'm sorry, play the help. So when we play an episode here, this is where it gets a little bit complicated, because now I'm actually connecting to Podbean, parsing out, finding the latest episode, and luckily they number them, so I can sort them and look for the latest number. And then what I'll do is I'll build a link up, and then I create a stream URL. This is part of the audio SDK bit. Set a stream URL. I create a token. You have to create. It's up to you to create a unique token for each user that's playing back. And what you're going to do with that token is store its state in a database. I'm using a DynamoDB database, but you can use a local database or whatnot. Because if they want to stop or resume, which the Amazon requires you implement, you need that token to be able to retrieve it back out of your database to know what offset they were playing at. So currently, we started off a set of 0. We start the file at the beginning, and then when they want to resume later and pause, we have to save where they're at and then resume at a different offset. Here I'm using DynamoDB and connecting in and inserting this token into the database to get things started. And then if I want to, pause, when I go to my pause intent, when I pause playback, all I do is alter that entry, tell it what offset I'm at now, and then when I want to resume, I'm going to look up that token and entry and then say, okay, that's where I'm at. I'm going to start playback at that point. So that's in a nutshell here. And this is posted on my GitHub page, so you can go through it and try it out, alter it, maybe make it do something else if you want. Have fun with it. All right, so what if you want to do more advanced stuff? So the Lambda stuff's great for making quick little things that are fairly simplistic as far as like its interaction model, right? But how do I if I want to make it log into something that I have an account on, like Twitter, or in this case, I've got another one, a VictorOps application, or something that I need a token or API thing for. How do I tell Alexa how to do that? Well, the only way you can do that is through account linking. And that means you're going to create your skill, and you're going to link it through OAuth, through Amazon's OAuth functionality, to your application. And that's what Grails fits in really well, because Grails has a great Spring Security plugin model. We've got a great OAuth plugin that works really well. And then there's also Spring Security UI. So you can bootstrap an app up really quick, have a UI, and manage it all without spending a lot of time on it. And it's all fully functional. So basically, we have to implement OAuth. We can do implicit or authorization codes. And then we use an account link card, and that's how it kicks it off. Here's the link to the documentations. There's some rules. If you want to set up your own server, it's got to have a valid SSL cert. There are no exceptions allowed unless it's in dev mode. If it's unpublished dev mode, you may use a self-signed cert, but the host name must still match the certificate. If it doesn't, you'll get really weird errors, and you'll scratch your head for a while trying to figure out what's going on. And so save yourself some time, do that. You can get certs for cheap. There's actually some people will do them even for free now. There was a guy, Greach, told me about it one site. I can let you know about it later if you're curious. That gives you free certs even, and it'll work. There's a list also of ones they've documented in support. All right, so I've got a skill hill called VictorOps. So my buddy Lee and I made this to kind of demo what would someone do in a business setting with this stuff. You know, a lot of people say, "Oh, this is a toy. I give it to my kids." You know, is there a business application for this? Of course there is. So I can monitor my systems. I don't need to keep pulling my phone out at home. Every time I walk by the kitchen, I can just say, "Hey, tell me any open incidents," and I know if there is anything, and then there isn't any, and I don't just keep going and not worry about it. That way I can kind of have peace of mind that something's not on fire, or maybe it is on fire, and well, that sucks. All right, so let me show you a little bit of a demo of this guy here. So I'm going to say, computer, open VictorOps.
Welcome to the VictorOps skill. Say list open incidents for open incidents or list teams or when am I on call?
So I can ask it one of three things. List open incidents.
Incident ID 7, Mongo's bout of disk space, started at Wednesday, May 3rd, 2017, 23:08 and 7 seconds GMT, and is currently unactive. Would you like to acknowledge, resolve, or go to next incident?
Acknowledge.
There was a problem with the requested skills response.
Oh, I hit a bug. All right. This one's not launched just yet because it's got some bugs in it. But that's actually going to a live VictorOps account. And when I have an incident opened, it will show me those. Let's try another one. Computer, open VictorOps.
Welcome to the VictorOps skill. Say list open incidents for open incidents or list teams or when am I on call?
There's another one. When am I on call?
Ryan_Vanderwerf's on call schedule is team example. Role schedule is rotation, standard, shift, standard on, team ops. Role schedule is you are on call between Monday, May 1st, 2017, 9 o'clock GMT until Monday, May 8th, 2017, 9 o'clock GMT. That is your on-call schedule for the next 3 days.
So that's an example of I just ask it when I'm on call. We've also got things where I can assign tickets to people or route things to people. So that's a real demo of a real live thing that you can use this for, and it's just one of many. Let me show you a little bit what this application looks like. This is a Grails app. So let me go a little bit, show you a little bit of how it's laid out. So we've got this is a Grails, latest Grails 3.2. There's a plugin that you use. So when you create a Grails app, all you have to do is add the plugin into your build.gradle. You add the Maven repo. Yes, it is. And then add in the plugin for Grails. It's down here. We have the Java SDK and then the Alexa skill. Okay, here. And that's all you need to get it going. So when you use the plugin, once you've got the plugin set up in your application, you can just say Grails create -speechlet space package name class name create speechlet. Now you can create a speechlet. You can have many speechlets in one Grails application if you want. And what that does, it will create two things for you. Under Grails app, you'll see a new thing here called speechlets. It works very similar to the way the Quartz plugin works if you've ever used the Quartz plugin in Grails, where it has a thing called jobs that it creates. And then it creates a kind of a template of doing that. So here, I told it to create this VictorOps speechlet, and this is something we've worked on quite a bit. But basically, initially what it'll give you is just these stubs, right? Override with nothing in it, and other than a bare example to make it work. And then it's up to us to add functionality and make it do things. So this looks just like the Lambda stuff, right? Just like the Groovy Lambda. There's a session kind of state you can store state in. You can do that between requests. It's a place you can kind of tuck things, just like an HTTP session in a regular browser. With the exception of audio things do not work with that. That's why I had to use a DynamoDB to store the state to pause and resume. That's unfortunate because they want you to have that state persist for days or weeks if you want. And we've got our on launch. That's when it starts. We just do a welcome kind of deal. And then again, here's our on intent. Here's where we're doing all of our routing here. So look, I've got open incidents. I've got, acknowledge an incident. Give me the next one. Resolve in the incident. I can do it by team, list what teams we have set up in the account, find out when I'm on call. You can ask it who's on call. So like, something's broken, who do I call? Rah! And then you say, who's on call? And it'll tell you, and then you can, go call someone and yell at them to fix whatever the problem is. And you can kind of decide when you want to list the open instances, how severe is that other thing, You may say, it can wait till tomorrow, acknowledge, pause it, let it sit there. Here's all that stuff. It's just interacting with a REST API that VictorOps has. Where we have a lot of functionality here with the Grails app that's cool. If we look in the application at Groovy, we've got all this stuff set up for Spring Security. We've got, let me hide this, give you more room. So we've got Spring Security set up. It lets all these resources in. I've got that. I've got OAuth configured with all my right classes. This part takes a little bit of fiddling, so you might want to just take my example apps here. I've got a Twitter one, and then I've got this VictorOps one, where you can just take the config file and then modify it to your needs, because there's so much stuff in here. There's like 3 pages of configuration, mostly for Spring Security and friends. Here's the Alexa skills options you can do here. You put your application ID in there. You can disable verifications if you want for debugging. Added a feature where it'll serialize requests. So if you get a really strange bug, it will write it out to disk when it receives it from Amazon. And you can actually play that back with curl if you disable the verification checks. So that way I can use curl command to spit something into my local copy of Grails. Maybe I want to debug it, right? See where things are going wrong. I can do that, which I do frequently, because otherwise I'm going to upload a WAR file, right, to a server somewhere, and then wait for it to restart, and then hit it again, and then find out it's broken still. Or I can run it on the Grails locally, replay that JSON, and then find out what the real problem is. It has built-in mail functionality, right? So it can mail your password, forgot password, all that stuff. So I mean, if I just go here, /VictorOps. So here's the Grails app running here. So I'm logged in currently. I can edit my user profile. And when I link my account, I created a profile, right? So now I can link my account to my VictorOps thing. So here I added my API ID and my API key, and I set that as active. I do the same thing with the Twitter app. It works the exact same way. This is all Spring Security UI stuff here. And sure, it could be a little bit nicer, but this is just kind of what you get out of the box. I can add a new one, right? I can add multiple credentials and then switch between them. And that's kind of the bridge, right, where I can say, okay, now my skill can do something with my VictorOps account, not someone else's. That's how you tell it to. And so once you set this up and create your account, you've done the linking. The linking happens here. So if I go find this, so if I disable the skill and then re-enable it, it's going to take me to account linking. And then it's up to me to log in and link my account. And right now I'm linking my account. It's going to say, do you authorize this thing to be doing it? Okay, now we're linked. Now it knows when I ask my dot to use the VictorOps skill, it uses my credentials. So that's really where I think the coolest part of the Grails app comes in. Publishing, there's some tips here. So when you want to make your skill, there's over 10,000 of them now you can access. And I think you can access a lot of them without even needing As long as they're published, you don't even need to install them anymore. You just, if you say, ask whatever their keyword name for their skill is, or open that keyword skill, it'll just open now. Which can be a good or bad thing. It'll start getting crowded with 10,000 some things, right? Everyone has to have their own unique word to invoke it. So if you don't provide all these things, automatic fail, you're not going to get your thing published. And a real person does test it. It can. I've taken anywhere from 2 to 7 days to get a response back, whether you've passed or failed, and then they'll tell you why. Some tips here: try to make sample utterances as specific as possible. More is better on sample utterances. You can be as redundant as you can until you're blue in the face, and it'll make your skill better. Use custom slots wherever you can. It'll help it understand. And make sure Alexa always responds to a request when prompted. You could make it space nothing back. That would be terrible UI, because then you don't know if it heard you, right? It would be like the husband skill. Just right? I'm listening, really. I just say nothing back. That's the empty response. Yes, dear. Again, use misspellings or phonetics in your code. You can make them misspell things on purpose for the speech that you say, but just don't do it in the card, or you'll look like an idiot. It'll be a bunch of broken, misspelled stuff when someone goes and looks in the Alexa app. Some gotchas. Use number type for numbers. Otherwise, it speaks the numbers or turns them into words when you get into your application, which makes it very hard to do stuff. Say a multiple choice question, right? You want to know they said 4. So you know which one they picked. Sometimes you have to use a literal type. They keep saying they're taking it away, though. That was basically literally interpret a string and then try to do your best to parse it. They're trying to get rid of that because it's got too many pitfalls and things that you can't really fix. So they want you to use types wherever you can. Some invocations for your skill won't work. If you give it any of these, for sure don't work. It has a hard time understanding Grails. It does Groovy pretty good. It calls Baruch from JFrog, it calls him Bottles. That's his nickname now. Again, self-signed certs must match the host name of the app while you're in dev mode. Can't publish, though. Follow those tips I gave you for SSML. Remember, an audio player, anything streamed from this stuff has to be an SSL. There's no way around it, even if it's the audio streaming. I've got a lot of source links here, so I can send the follow-up with the slides. These are the links to all the things. A lot of them are in my GitHub repo or in my Vanderfox repo. GitHub.com/rvanderwerf or GitHub.com/Vanderfox. All of these things are there. But I've got a lot of useful things that I use to develop with are all in here. Especially that lazy bones template. That makes it easy to spit out a Lambda thing. That's the thing where you could have a skill running in 10 minutes, right? Doing something. That's what we do in our workshop. So I'm going to be doing the workshop. I've done in Europe and US this year. If you go to any of the great comps, we'll do a hands-on workshop for 4 hours of making the stuff hands-on. So you'll walk away having built stuff and you know how it works. All right. Special thanks to Lee for helping me with this stuff. And Benoit Haydard gave me the sort of framework template of how to use the Lazy Bones template to make a Gradle app. I based it on his Groovy Lambda stuff. All right. And that's it. Yes?
Is there a way to fire an event like instead of we asking Alexa response on its own? Like at the evening time, 9 o'clock, if the garage door is open, it says the garage door is open.
Nope. That's the cardinal rule that they won't let you do, is it cannot do something without being invoked first. The only exception is the alarm function, which is actually, that doesn't actually go to the cloud. If you say, computer, set a timer for 5 seconds.
5 seconds, starting now.
You're right, it's pretty short, right? But that actually doesn't go to a cloud thing or anything. And so that's the only exception where it'll come back and do this. But I could also say, set an alarm for 7 a.m. tomorrow. I use this as an alarm clock. Computer, stop. Computer, stop. There we go.
Is Google the same way?
Yes, they're the same way. Google's gotten a little more evil with it. They tried a thing, they stopped it pretty quick because people went nuts, where they started spewing ads and stuff. So it would start advertising Disney movies, Moana, I think it was what it was, and then people lost their minds, and so they pulled it out.
You know, if they're considering the ability for it to say you have a new incident as opposed to you have to invoke it?
You would have to make it invoke something external, right? Your phone or whatever. There's an intercom. I heard they're going to make an intercom type thing for Alexa. So because of that open SDK for making devices, the voice SDK, they're going to be putting Alexa in everything, like your refrigerator, your dishwasher. They just made a big announcement today that next Ecobee is going to have Alexa built into it. There's some cars built with Alexa built in. Some people put it in their cars. They get a little battery thing and stick this in their cup holder because it's the perfect kind of size for a cup. Put it around their car. The intercom thing is the only thing I can think of. There's also a patent they filed for doing phone calls over it. Currently, you can't really make a phone call, but they do have skills like for elderly people. Say they've fallen down and they can't get up, right? The typical, commercial that we all saw that was kind of hilarious, but there's people that really use this where they can call for help if they've fallen down, So there's disabled people use this for stuff around their house and home automation. It's making, all these things make people's lives better now ways I hadn't even thought of. There's several user forums they're not technical people, they're just people using it. They've come up with really crafty ways to enrich their lives and use this stuff. But there is no way to make it do that afterwards. I think they're worried that it would creep people out and they wouldn't buy it because they wouldn't, someone can make a skill and be evil, right? And just start screaming at 2 a.m. right? You're just like, what's going on? You never know. So maybe give you some heart attack.
The power of being able to have workflow alert somebody that you have a new incident or your stock price dropped below blank or your customer sentiment is trending down.
Use tricks where it would actually make your phone do something and it would say something. It would evoke you, and then your phone would say something, and then it would say something into this. So if you have your phone right here, it would say, Alexa, do something, right? So the people are getting crafty, but yeah, you could do a lot more with these if you were allowed to do that. And maybe if they come out with an intercom kind of model, you'll be able to do that, but currently you can't. That's one of the limitations. It's really a better, this user interface, you don't really want it to talk to you a whole lot, right? It's kind of not a great way. You can get a lot more out of a screen than I can it's speaking because it's slow. It's just a good way for me to put things into it because I can talk to it. That's the cool part. Anyone else have any questions or anything? Ideas? No? All right, well, thanks, everybody.